Hello everyone, my name is Anil Gupta and today I'm going to talk about how TrueCar is using Apache Druid. So a brief background about ourselves. So TrueCar is a leading digital automotive marketplace. We have more than 10,000 dealers in our network and we are one of the biggest new car marketplace in US. And then we also have more than 250 affinity partners. So we help Uber, Sam's Club connect their customers to dealers and get the best car that they want. I've been working at TrueCar since 2014 as a data engineer, and before that, I was working at Intuit as a data engineer. I've been a long time user of distributed systems, so I started my journey into distributed systems since 2010 and have used literally most of the famous softwares in the Apache community for data like HBase, Phoenix, Spark, Elasticsearch, Kafka, and I've done some contributions to Apache HBase and Phoenix. So now let's talk about our journey of Druid at high level. So we started our POC of Druid in Q4 of 2019. Then as an outcome of the POC in Q1 of 2020, we selected Druid as our new OLAP database. And then we deployed Druid to production in Q3 of 2020. So taking back in time and then let's go in the chronological order. So in the year 2019, we were already running our infrastructure in AWS. We have been running Hadoop, Elasticsearch and stuff like that in our stack since 2014. So our data stack is pretty stable in that aspect that a lot of tools have been used there for a long time. We migrated to AWS in 2017 and right around that same time, we also started adopting streaming applications rather than batch applications that would just run on MapReduce and Spark. So then we introduced Kinesis and then Spark streaming, and then we were using just HBase to do OLTP workloads over there. And then we had Redshift for our analytical reporting. Most of the reporting is done from Redshift. And then Elasticsearch is there for supporting our website and doing free text search and making sure we can do very fine refined filtering on our website to help users find the cars that they want. As we started our journey moving from batch applications to streaming applications that are more interactive, we started seeing there is a gap in our architecture because we had a pretty decent stack with a lot of tools available. We have HBase for OLTP operations at scale, and then we have Redshift for data warehousing, but all of them they had certain limitations. Like Redshift is very good for batch ingestion, but if we want to do near real-time ingestion in batch, it's not really conducive for that. And then HBase is really good for doing reads and writes at scale, but it's not really good for aggregations. If we start doing aggregations in HBase, it starts hampering the job that are supposed to do like small lookups and scans and writes. So then the overall stability of the platform starts suffering. Then we also noticed one more thing that it would be nice to have a native JSON support to a database because a lot of data exchange was happening in JSON. And we also use a lot of Avros internally at TrueCar. Then one of our bigger data set, which is Clickstream data sets, it was being sourced from BigQuery. And the cost of BigQuery was going higher because we were charged per query. So if more and more people are running query, our cost was just constantly going up. And we didn't have any control on that. We looked at a lot of systems, but eventually we just wanted to compare OLAP systems. We knew right out of the gate that we cannot compare Druid and HBase and stuff like that. So here is like a high level comparison of Druid and Redshift. So Druid is meant for streaming based ingestion. It works really well with that. Obviously, it can do batch based ingestion also, but that was not the selling point for us because we already had Redshift. If we just wanted to ingest data once or twice in a day, that works fine with Redshift. So for us, the selling point was streaming based ingestion, and the ingestion latency in Druid is in milliseconds, while if we look at Redshift, the ingestion latency is much higher. Obviously, you can push data through Kinesis Firehose to Redshift, but the latency is still going to be in minutes. You can cut it down to seconds, but you are just pushing the boundaries at that point. Druid is already partitioned on the basis of time. So all the segments are already divided, and we had a lot of use cases where we wanted to look at the data on the basis of time as a critical dimension. We can do it in Redshift, but it just works much better with Druid, with time intervals and all that. Another thing, it provides native JSON support. In Redshift, we would constantly need to do like flattening of data and stuff like that. Druid handles JSON arrays much better than Redshift. Then another thing is theta sketches and hyperlog. These are very cool approximation metrics that you can do at a fraction of time and memory requirements. One thing that we found lacking in Druid was the join support, but for our use cases like Clickstream and stuff like that, our data was mostly flat. So we decided to kind of punt it and then look at it later. Redshift is pretty good at the full join support. So that was one of the things that was lacking. Then another good thing with Druid is that it supports rollup at ingestion time, while Redshift doesn't. And last but not least, the foundation of Druid was set with keeping modern data analytics in mind, where the founders wanted to analyze Clickstream data. So that's why they supported JSON, came up with a fully distributed architecture and all of that. But as compared to Redshift, it's built on Postgres, and so it's more of a traditional warehouse. So as per our analysis, this is a Venn diagram that we think it fits in, where Druid is a time series database because it arranges all the segments on the basis of time interval. It does very well in using inverted indexes and bitmap indexes, but it's still not a full search engine. Like, it doesn't support all the text search, which is, I'm pretty happy with that, because with Elasticsearch, what happens when you start ingesting data at scale? Some people like to use Kibana as an analytical tool, but it doesn't really works when you start throwing billions of records in a table or an index. So that is where we found out that it's still using a lot of good stuff to give faster results, but it's the memory footprint is much lesser. So it fit in the use case that we wanted. Post POC, we updated our architecture. So this is how the new architecture looks, where we were able to offload a lot of Spark and H-based jobs directly to Druid. And then the way we write data to Druid is mostly via Kinesis. All the data is flowing in through Stream and just going directly to Druid. For the reads, we usually don't run a Spark or a MapReduce job. We just run a simple query so that we are not hammering the cluster, because we don't need to do that. Druid in itself is a distributed data crunching system. So it takes care of doing the data crunching and heavy load, and then returns the result. Once we get the result back from Druid, then maybe if we want to run a Spark job on the output, as per the business logic, we might run it, but apart from that, we don't do it. So eventually, we have Druid as a database as well as Redshift. Both have their own purposes, because Druid is very good for that near real-time analytics. We still have a lot of use cases where we need to do joins and stuff like that, so we still have Redshift in our stack. And then HBase is there for OLTP. So as you can see, we like using horses for courses. There is a use case for all these databases. So we still have all of them in our stack. We just wanted to make sure we are not basically having a platform that becomes unstable because we are trying to use a tool that it is not meant for. So now let's talk about some use cases. So the first one is the Clickstream. So let's talk about the data ingestion. So over here, users' events from our websites and partners' websites are flowing into the stream. So they go from our website to AWS Kinesis. Then we have a Spark streaming process where we can enhance and normalize and cleanse the data and then push it into HBase directly. We are pushing it into HBase so that if we need to update the data for some wrong processing or something happened, we can do that very easily as compared to Druid. So in order to update data in Druid, we have to reprocess the entire segment. So that's why we keep data in HBase for all the OLTP purposes. And then if we have applications that just want to do very quick lookups and all that stuff, we can still point them to HBase. And then from Spark streaming process, we write the data to Kinesis, and then it flows into Druid. On a typical day in this Clickstream table, we are pushing around 20 million records, but we keep around 3 years of data, so that table has around 20 billion rows. So what did we get after doing this? Well, the first thing is that we reduced our Clickstream data analytics latency from hours to seconds. So initially, since we cannot use HBase for Clickstream data analytics, we were using BigQuery because it was flowing through Google Analytics to BigQuery. BigQuery has a latency of 1 day. So we were able to cut down all the latency from hours or 1 day to seconds. The other thing that we got very fine-grained control over the ETL of Clickstream data. And then basically now we were able to see the user activities on our website within minutes or hours rather than waiting for 1 day to figure out what is going on. So all these things we were able to achieve by introducing Druid in our stack. Now let's talk about some other use cases. At TrueCar, we have around 60 or 70 production pipelines that are running. And these pipelines usually are basically not using any of Hive or Peg or any of those tools. These are all custom logics written in RDD or custom MapReduce jobs and stuff like that. So franchise pricing tool is another machine learning based pipeline where we use it to predict the rates for our dealers. In this pipeline, we count the distinct users per PAG and zip code for last 90 days. So this pipeline needs to query around 2 billion records. We had this pipeline running in a Spark and HBase job because the data was there in HBase. It was taking 4 hours to run with like 50 or 100 Spark executors that are just hammering HBase all the time. We were able to migrate this job to Druid and free up all the resources from the Spark cluster as well as HBase cluster, and it would just run in 5 minutes. So this was a humongous change. As you can see the impact over there, the job performance went up by 48x just by using the right tool and simplifying the architecture. Another one is we wanted to develop a filter on our marketplace so that the users can search car on the basis of monthly payment. For this also we need to ingest our vehicle offers data in real time. So for this, all the calculations and other stuff that we need to do, we could have done it by using a Spark job running on, a lot of our data is there in HBase just for the OLTP reason. We have a bigger cluster over there. We could have done it with a Spark and HBase aggregation pipeline where it hits the table and collects the data and then we do aggregations in Spark. In this case, we didn't need it to do anything. We just had that data flowing in Druid and we were just able to write a simple SQL query and get the output. So this is another ML based pipeline where we want to calculate the propensity of a user buying a car. In this case, we want to get all the distinct action for a user in the last 24 hours. It usually scans around 18 to 20 million records in Druid. But if we were using like HBase, then it would scan the entire table, and the entire table has 20 billion records. So as you can see, because of the time series nature of this database, we were able to leverage that and just simplify the pipeline and run this entire thing in like 30 seconds. So what's next for Druid at TrueCar? So we have been, we always believe in trying to get the maximum out of a tool set that is part of our stack. So we want to, this year we have few use cases where we want to try joins. I know joins are not fully supported, but there is some versions of joins that are supported. So I'm constantly talking to the Druid team to see where we can take them, and then try out theta sketches. They are pretty cool things for doing some complicated metrics. So gonna try out that one. And then right now we have a pre-production pipeline that is ready to go to production, where we want to start observing the metrics of our data platform itself, because we have a lot of jobs running and our cluster is shared across the entire organization. So we want to see if we identify anomalies in our job, the Spark accumulators and MapReduce counters, everything is going to be pushed to Druid, and then we want to leverage it for finding anomalies in our data platform itself. And that's all I got. Thank you.